Okay, so we're going to start on time, and this is the last session in the performance and capacity track 5.0. And Jelly's going to talk about transforming mainframe performance, leveraging modern tools for enhanced efficiency, which I certainly can relate to, being somebody who tinkers with stuff. Okay, take it away.
Thank you, Martin. Hi, everyone. So, my name is Justin Panambayan, and today I'm going to talk about transforming mainframe performance, leveraging modern tools for enhanced efficiency. And I'm a product manager for Dynatrace. Yeah, so let's begin. And this. Wait. All right. Well, mainframe monitoring. When we talk about mainframe monitoring, what is mainframe monitoring? And most importantly, what does mainframe monitoring entail? When I started out work or when I moved to Europe, I started out as an IBM system operations. And I work in Brno, Czech Republic, and this is our office. And when we talk about mainframe monitoring, my job as a SysOps, well, we monitor the list of scheduled jobs, we monitor the batch process, and we normally have like um, shifting schedule. We monitor batch process system performance, the storage. We have the specific error messages that we look for. We have specific alerts, and we reply to WTR messages. We call it WTR messages, and then we report abandoned jobs. And when we respond to situations, or whenever we monitor stuff and there's a situation or there's an issue, the normal response that we do as sysops is we have this documentation, we have this fix it book, and we look at the documentation and we see, this is the error message, this is what we're gonna do, the step-by-step process, blah blah blah, and that's how we handle things before. But what happens if the error is actually unexpected? Like there's nothing in the documentation, you don't know what's happening. Well, as a sysops, the first thing that we do when this situation happens, well, first of all, well, we panic. Um, And then the second thing is that we calm down and then we escalate. There's this escalation book that we have. We follow it. The first, second, third escalation. We call those numbers. And then after that, we wait for further instructions. We anticipate wait for further instructions, and whatever instructions that we were given, we follow it. And so going back, because I started out as an application developer, I'm a couple developer. So I understand both sides. And normally the question that I ask whenever I I have instructions. When I was given instruction and I follow it, the question is that do I have an idea what happened? Like as a sysops, what is the error? What is the issue? And who is at fault? Normally, I don't know. And with gut thinking, I always ask myself, like, is there a better way to handle this kind of situation? Where me, as part of the operations team, can I be more involved in the investigation? So I thought about this back then, and fast forward, I joined Dynatrace as a support engineer, and my role in Dynatrace is actually to support companies who uses Dynatrace for their mainframe observability. So first of all, I have a question in my head. What is mainframe observability? I have no idea what it is. And so I try to investigate, like try to research what mainframe observability is. And I'm not going to bore you with some long explanation about mainframe observability, but these are the key things that I want you to remember. Well, mainframe observability, it's monitoring and gaining insights. It's collecting metrics, traces, and logs. There's Dynatrace, Datadog, IBM Instana, Grafana, and those are the observability platforms, and then Open Telemetry. So when I look at this, and I said, huh, I have more questions. I don't have answers, but I have more questions. Like, I had a hard time understanding the concept and terminologies because most of them are new to me, coming from a pure mainframe background. I mean, most of these are new. And so, um, as part of my process of learning, the first thing that I do to understand or to familiarize myself in learning new terminologies is that I use analogies. And these analogies are actually familiar to me. So it would help me. So there are five key things that is important in observability. And these are metric, traces, logs, observability platform, and open telemetry. So let's go through it using analogies. So if we talk about metrics, metrics are like the earth. They are solid and stable understanding of your system performance. It basically contains solid quantitative data about your system performance, CPU usage, memory utilization, response times. It's that stable foundation of understanding of how your system actually performs. The next one is traces. And traces are like the air, it flows through the system. So if you have a request from mobile to your mainframe, you can see all of those information gathered and how it is connected from one request to another. The third one is logs. Logs are like fire, and these are detailed record of your system events. It could contain warning signals, error messages, alerts, something that needs immediate attention. And you use logs to investigate such alerts or such error messages. And the last one is observability platform and open telemetry. They are like water. They adapt to different environments. They have a vast technology base that they support, and it provides clear visibility. It visualizes whatever technology that you want to gain monitoring or you want to gain insights from. And if you combine all of this together, metric traces, logs, observability platform, and open telemetry, well, you get mainframe observability. And that's the basic understanding that I got from mainframe observability. And so when I was learning this, I thought to myself, I thought about my sysop days, like when I have those questions. Like I realized that hey, the more that info, but I just thought about it and asked those questions again. And then I realized the more that I get more information, the more questions that I ask. And so some of the questions that I have is like the first question that I have when I was in SysOps is that do I have an idea of what happened? And then, oh, sorry. And then now that I know mainframe observability, is there a better way to handle those unexpected situations? And so I got me excited. And the the more that I know, well, I ask more questions. And so I ask another question. Like if we leverage modern tools like Dynatrace as an observability platform and open telemetry, how can I actually enhance how can I actually enhance mainframe performance? And mainframe performance is a very vast topic. And so what I did is like, all right, as a sysops, I have to step back. When I said mainframe performance in a sysop point of view, what do I mean? What does mainframe performance mean for a sysops? And as a sysops, mainframe performance means or enhancing mainframe performance means answering to yet another two main questions. And these two main questions is number one, is it mainframe's fault? And number two, if it is mainframe's fault, what is the problem and how can we fix it? And so with these vast questions that I have in mind, I need to understand mainframe observability more. And the next step of for me to understand things is to use cases. And this is how I learn. And so what I did is that I formulate use cases to understand mainframe observability better. So I just want to warn you that these situations are basically made up because I just needed to learn. Excuse me. So the first question, is it mainframe's fault? So I created this situation. And the situation is that the bank's application is taking a long time to display the customer's account statement. And the customer service called me and they said, hey, can you check? Maybe it is mainframe's fault. So me first is I was like, why? Why is it mainframe's fault? But I need to prove it. I need to check. I need to show that I need to tell the customer service that, hey, maybe it's not mainframe's fault, but I don't have any proof. So just to tell you that I am using Dynatrace in the screenshots. But you can definitely use other observability platforms. They do have the same features, um, similar to what Dynatrace has. So there's this called a user session in Dynatrace. And whenever there's a user who uses an application, it logs the flow, the the step-by-step flow of how the user is actually using that application. So we can see here, this user um, is using the Easy Travel mainframe application, and we can see that it has this experience score of like the session duration is 14 seconds, and it was really frustrating. The user experience is very frustrating, and when I checked it, I also saw that the operating system that they use is Windows 8 and an Internet Explorer. Yeah, maybe that's it. Maybe that's why it's frustrating. They're using Internet Explorer. But I cannot say that to the customer service representative. I need more proof. So what I did, or what I could do, is to dig deeper. I could check the waterfall analysis, and the waterfall analysis is just the flow, or what the request flow, like what is the step by step, what are the requests that was loaded in the website, blah blah blah. And here it shows that, hey, it stopped at easy travel booking transaction, and I could view the trace. So let's click the trace. And as I said earlier, the trace is like the flow of requests, and I could see, hey, the flow of requests here, I could see it. It started from the web server, and then it stopped at the customer fronted, nothing more. If I check the service flow, there's nothing more. It never connected to mainframe. I could check on the error details as well, and it's an internal server error, and there's nothing more. So I could now show this that, hey, this is not mainframe's fault. I have proof, and as a system, this is very helpful because one, I answered the question: is it mainframe's fault? Is it mainframe's fault? No, it is not. I could tell you, I have proof that it never actually arrived in mainframe. It stopped all in the front end. And that's very helpful. So now I have answered I have now an answer to my first question. And the second question is that if it is mainframe's fault, what is the problem and how can we fix it? So another situation is that the reports were generated for the customer has missing data and they want to know why. So of course, like if you're a customer and you're looking at your account transaction and there are no information there, you 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 wonder why. All right, so let's investigate this one. Another thing that I saw is that there's a problems page, and the problems page is basically an alert page. And during the time of the generation of the reports, there was an alert that was created, and I can see that there are impacted services, and the impacted services are mainly on kicks. And it says here that there are 4 service failure rate increase events. And I don't know what that means. So I could actually like analyze that failure rate degradation and understand what that actually means. And if I dig deeper, I could say, hey, there are exceptions. There are actually exceptions in the DB2. Hey, what's going on? Let's check out the details. And then we're going to go to the trace. And in the trace, I could see the flow again. And there's this metric information that, hey, this is the SQL that was executed. These are the old information. It goes from MQ into the kicks, and it calls the DB2 tables. And there are red lines right over here. And so we can click on the red lines, and it gives you this detailed information of what the exception is, and there's a problem. And now, as sysops, hey, I know what's the problem, and I could see it. I cannot fix it, but I know who, or I know the team that I could contact to fix this. Maybe they can investigate further. But and it's very helpful for me in that investigation part as a sysops. So then I thought, hey, observability is great because now I have answers to my questions. And what are my questions again? Do I have an idea what happened? Yes, yes, I do. I saw um, I saw the flow, and I know what happened. I have proof um, that this is the error and this is what happened. And is there a better way to handle those unexpected situations? If if I have mainframe observability before, yes, because as I saw that I was able to see the flow of how the problem started. I saw the user journey. I know the right team to contact. I know who to talk to. And more importantly, I have proof that, hey, these are this is what happened and you are the right person to contact to. please continue the investigation. So me, as sysops, I am more involved in the investigation, and also I am more involved with finding out what actually happened. And maybe I could also help in brainstorming. I don't know. But there are more information that I got, and I could definitely help more. With that information, with all of this, well, now, how do you get started? If you're like me, how do you actually get started? Well, I was hired in Dynatrace, so I could use Dynatrace. But if you don't have it, basically, you can use any other observability platform. But in this talk, I'm going to talk about OpenTelemetry. And OpenTelemetry, again, I'm not going to bore you about the details of OpenTelemetry, but I'm going to give you these key points. OpenTelemetry is an open source. It's part of CNCF. It also collects metrics, traces, and logs. And it has a large collection of code instrumentation, and it has a collector. And if you want to know more about OpenTelemetry in a mainframe perspective, you should watch this video. Rudiger Schulze was able to explain OpenTelemetry basics and to give it understanding in a way that how a mainframer thinks. And I really like it. So you should go watch this video. But in this talk, I'm going to focus more on these two things, the code instrumentation and the collector. And I think it's really important to show you, like, because this is how I did it, how I started as well. So there are two things when starting in with OpenTelemetry. And we need to understand it better because as if you want to create an observability, this is what you're going to do. So one is code instrumentation. And code instrumentation, it's just this, in simple terms, it's injecting an observability agent into your application. It means that you have this observer and you put it into your application, and that observer will record everything that you want it recorded. So for example, I have a JavaScript application. Maybe I created a JavaScript application and I use OpenTelemetry JavaScript instrumentation. So I want to observe all the HTTP instrumentation of my JavaScript application. And in this JavaScript application, I actually um, call the Zoe SDK. So I have Zoe APIs. It calls the mainframe, and I want OpenTelemetry to create a log for me of the flow on how this this JavaScript application actually calls all of those APIs. And I want a visualization to my observability platform. And so I did a sample project, and I presented this before in the Open Mainframe Summit in New York back in 2023. And this is what I did. I created no, I didn't create it, but I downloaded a, a pre-programmed Zoe JavaScript application. And so I have I have all this code and all these APIs being called in this JavaScript program. And then I I created also an instrumentation program. So this instrumentation or this auto instrumentation only specifies that, hey, I'm gonna use the HTTP instrumentation here. I'm gonna use Express instrumentation. I'm using all the I'm importing all the OpenTelemetry resources, and then since I'm using an observability platform, I'm gonna tell you that, hey, this is the tenant URL and this is the API token because this is important. And this is the location where you're gonna submit this. So in Dynatrace, they specify that if you want traces, it should be V1 traces, or if you want metrics, V1 logs, whatever. But it depends on your platform. So for me, I just specified this one. And then now I have two things. I have an instrumentation program and I have a Zoe program. And the way that you execute them, I use Docker to execute them. Um, you just fire it together. So when you execute them together, it means that, hey, OpenTelemetry instrumentation, I want you to monitor this program. Please tell me what's happening. And the result would be that there's a sample trace that OpenTelemetry will create. And you can see it in the console log if you actually displayed it. So you can see all of the traces that that Autel is creating. And if you go through your platform, you'll be able to see the information in your platform. Just a disclaimer, you don't have to use that observability platform if you want to create those traces. OpenTelemetry is vendor agnostic. You can actually just display it in your console log if you want to. The observability platform is just useful because it's a visualization. It's easier to see it and it adds more information. So in here, you can see that there are a lot more information added here. And if you want to see the demo, I added a QR code here. You can scan it. This PowerPoint will be uploaded, so you can just check it out later. And there's another way to get to to get more information, to get more traces, metrics, and logs from all of your application, and that's called the OpenTelemetry collector. And from the name itself, it's a collector. What does it mean? It means that the OpenTelemetry collector receives data from various sources and it exports data to various backends. So the collector is like a middleman. It collects a lot of telemetry data from a lot of application and combines it and then submit it to various backends. And it's vendor agnostic, it's very versatile, it's expandable, and it has this huge number of supported technology. So in this example, I can show you that. All right, so we have this TypeScript or the JavaScript application that we did earlier, and then I have a Java application. Maybe I'm monitoring this Java application for its logs. I'm using I don't know, I'm using IBM Instana to get the Linux One data metrics and logs here, and so I'm monitoring it, and then I have a .NET application as well, and I'm using, I don't know, different one, maybe Datadog, and I'm getting all of the metrics there. And instead of me just having it um, in a multiple location, I could use the OpenTelemetry collector to collect all of them and just pass it to an observability platform. And that's the beauty of that OpenTelemetry collector. And if you want to know more about this, actually, this is very helpful, I think. You can get started by just going to opentelemetry.io. They have a really great place to get started. They have samples and you can basically just research it. So just to give you some example on the how this collector works. Uh we have this an ongoing project. I can't really talk about it that much, but the project is that it just collects mainframe information and uses the collector to submit it to an observability platform so we could visualize it better. And we were able to gather a lot of information from Kix. So for example, we have this Kix transaction gateway, and we're able to get the garbage collection. We were able to get connection manager threads, uh, the heap count, um, response time, the response time, and we were able to massage it in a way that we want. Because if you're using uh, on the observability platform, you can actually create your own charts. All you have, if you have all of this data extracted from Mainframe, you can actually create your own charts. And not just that, you can actually get from a different or from different Kik servers, all of them. You can extract all of those information and then visualize it in a way that it's easier to monitor it or to observe your system better. Another one that we were able to capture is the RMF virtual storage activities, and you can use those like dashboarding and charting. And I think it's super duper helpful having all of this information at hand. And so now, what are my key takeaways? So with all of this data that you get using OpenTelemetry, it's actually just a starting point. It's the tip of the iceberg. And how can you transform mainframe performance and enhance efficiency? Well, by leveraging the modern tools, you can leverage anything you want. You can leverage OpenTelemetry, you can leverage Zoe, you can leverage the observability platforms to visualize things and enrich your experience. You can use that to have a clear view of what happened. You can have a root cause analysis, you have a user session, you have traces to follow, you have logs and metrics that you can check, you have charts, you have dashboards to help you visualize what's happening. And honestly, as a sysops, this is way cooler. It's not just like I'm going through a manual and checking um, the error messages that I need to check. I have a more understanding. I could get more involved in the investigation. I could compare what happened last week, what happened yesterday, what you know, and it's pretty cool for me in in my perspective, and because I can have a more informed decision making on how to handle things. It's not just, hey, uh, this is the error message. It's not part of our book. Can you please investigate? No, I could tell you more. It's it's a it's a collaboration between teams because I was able to see more information regarding the problem. And another thing that you can leverage to transform mainframe performance and enhance efficiency is to leverage actually sorry is to leverage your own knowledge and experience, and you don't take that for granted. Actually, your knowledge and experience is very, very important, and you have something to contribute. I was able to use my experience when I was a sysop, when I was a COBOL developer. I was able to use all of that and to think of use cases on how I could help the customer better. So I was able to revisit my pain points, and you should do the same thing. So when you're trying this out, when you're trying to think about this, leverage your own experience, revisit your own pain points. How can you make things better? And then after that, you investigate, and then you innovate, and then after, of course, you advocate. And this is the most important thing. You advocate. You share your experience, you share your knowledge so that the next generation could actually learn from you. And they're gonna pass on that knowledge as well. Well, that's it for my presentation. Thank you so much for attending my session. If you have any question, please feel free to ask me. I think we still have a lot of time actually. And don't forget to give feedback for my session. Thank you so much. Hey Martin.
Hey, I've got two questions at least. This is
Yeah.
this a health warning. So this is the first one. Do I need to read it out? I guess I probably should. So the question really is, so you gave a very nice example that I know a lot about actually in terms of the data, which is RMF virtual
Mm.
storage. The specific question, which is the question one, really is how you get stuff out of RMF into this. The second question, which I won't bother writing now, I'm talking, is in general, how well built out is that OS in terms of provisioning probes, the data, whatever you want to call it.
So right for the question one, I really cannot tell you um, how we are actually getting that RMF data because it's an ongoing project.
Right.
But if you're really interested, you can message me, and I can tell that to you in
Right, it's a
private.
confidential thing. Okay, get that.
Yeah, you
You
can. I
say
can
that, then
tell you
I
in.
will put both feet in my mouth and say it. Yeah.
Yeah, I can tell
Okay.
you in private, but not in this conference. But yes, it's an ongoing project, and I cannot share more. Once it is public, I would definitely share it to everybody. And can you please repeat the second question? I actually
The
didn't get it.
second one was in general, how well built out is the instrumentation on the ZOS platform? Or are we, and the other part of that, I guess, is, or are we really relying at this stage of people like customers instrumenting their applications directly?
So far, the 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 things that are very stable is when you actually create your own um, Node.js application. So if you're talking about extracting information directly from mainframe, like from a COBOL program, that's not happening right now because there's no SDK for that.
Right.
And what we have, what OpenTelemetry offers is SDKs for JavaScript, for Java. So you have to go through that technology. But we do have a work group currently that is working on extracting information from mainframe. So it's still young, but there are plans to have an SDK for your COBOL programs or for getting information from DB2, from Kix, from your ZOS itself, from RMF as well. And it's a open telemetry mainframe work group.
Right. Thank you.
You're
So
welcome.
it's work in progress. It's early days. Is the mood music on this? That's really
The-
useful.
Yeah, and yeah, and I agree. It's very very useful, and we're also like investigating that part, and hopefully one day we will be active in that work group as well.
Cool. Thank you. Okay, so there's time for questions, to state the obvious.
Yes.
This is when I put my chair hat back on briefly. Any other questions from maybe customers or other vendors or whatever?
Yeah. Or if you don't have any question, do you have any feedback? Or just a conversation. This is a safe space.
Will also be a safe space is the face-to-face conference in the autumn, and maybe this will be a bit further built out by then, maybe. Okay,
Hopefully.
let's give a
Well, all
couple.
right. Yeah. Okay.
Maybe one, maybe 30 seconds only.
Okay. All right. Well, I guess there's no questions for me. Um. Yeah.
Okay,
I
so
think.
I'm gonna close the stream. Other streams seem to be ongoing, so I may well see some of you there. So thank you for everybody who's shown up in the various sessions of this stream. Thank you for presenting.
Yeah. Thank you so much. Thank you very very much, and yeah, appreciate everybody who attended the session. Thank you. Bye.